Okay, so today we're going to do some circuit analysis based off of this circuit where we want to find I1, I2, I3, and the voltage VA. We're going to need to use KCL and KVL, where KCL was our conservation for current and KVL was our conservation for voltage. So, based off of the battery's polarity, we can assume that the current is going to take this path along with this path because it wants to go from positive to negative. We can start with our KCL equation at the node right here. So we can say I1 plus I2 is equal to I3. And then we have our two KVL loops. The first one we can start here and use this loop, where we will have V1 minus I1 R1 minus I3 R3 is equal to 0, just going around there. And then our second loop, we can go counterclockwise, where we will have V2 minus I2 R2 minus I3 times R3 is equal to 0. So what we can do, we can plug in the first equation into the second and third. So our second equation will be written as this. And our third equation will be written as this. So from there, we have two equations and two unknowns, I1 and I2. We can easily solve for either one of them. In this case, we will do I2. So this will be what the current is for I2. Now we can plug I2 back into these equations to actually solve for what I1 is. So now we have solved for I1. And notice that I1 is given in terms of all the voltages and the resistors, which should be given, so we can calculate an actual numerical value for I1. Based off of that numerical value, we can plug that into I2 and get that as a numerical value. Now we know that I1 plus I2 equal to I3. So we know that both of those are a numerical value, so I3 we can get as a numerical value. Now, off of Ohm's law, we know we can calculate what VA is based off of what I3 is and what R3 is. So now we're able to calculate everything and we know all the currents. We know what the voltage is at VA. So for an example, if V1 equals 10 volts, V2 equals 8 volts, R1 is a 1K, R2 is a 4K, and R3 is a 2.5K, then I1 will equal 2.73 milliamps, I2 will equal 0.178 milliamps, I3 will be equal to 2.9 milliamps, and VA will be equal to 7.27 volts. All of these are depending on how or where you cut off your rounding for all of these. So that is how we do our basic circuit analysis. Now let's look at if we don't know how we should estimate the current directions. So let's say we have this setup now where it's the exact same circuit. Let's say we put I2 the wrong way, and we'll see why that really doesn't matter. So again, we have our KCL, except now we have I1 is equal to I2 plus I3. We have our first loop here. We have V1 minus I1 times R1 minus I3 times R3. And then our second loop is a little bit different this time. You can start it wherever you want. I always choose to start it here. So we know that we are going the opposite direction from what we have the current labeled. So we will have I3R3 going up, hence the positive, minus I2 times R2, and then minus V2, because we're going back down, equal to 0. Now we can plug in I1 into this equation, and then equation 2 and 3 will be in terms of I2 and I3. So we can do the exact same substitution as before, and now we will find that I2 is equal to V1 minus I3 R1 plus R3 over R1. We can plug I2 back into these equations and find that I3 is equal to V2 plus V1 R2 over R1, and that is all over R3 plus R2 over R1, R1 plus R3 in parentheses. And then we can solve for I1 equals I2 plus I3. And then we can say VA is equal to I3 times R3. So the exact same way. But if we plug in the same values as before, which were V1 equals 10 volts, V2 equals 8 volts, R1 equals 1K, R2 equals 4K, and R3 equals 2.5K. What we will actually find now is that for I2, it will equal minus 0.178 milliamps. If we look at the last part, right here, I2 was 0.178 milliamps. So we've got a negative sign on it. And what the negative sign represents is that initially up here, we labeled the current going from left to right, hence the arrow. But because we have that negative sign here, we know that the current would actually be going this way. So it cleans up your notation for how you would actually write the direction of the current. So that's all that happens if you label your currents the wrong way. KCL and KVL for circuit analysis clean itself up just based off of the math. So